Good morning, everyone. Thank to DSA for inviting me and let me share some experience on math optimization at work. I'm Claudio Caremi, I'm partner at Optit, and where I'm also responsible for two business units, logistics and waste. A few words about Optit. Optit is an innovative SME founded 15 years ago and grown up as a spin-off of the University of Bologna, an accredited spin-off of the university. What we do, in 2 words, we build and manage decision support systems for several industries such as logistics, waste, and energy. We are more than 40 people located in our headquarters in Bologna and the software factory in Cesena. Today, I want to give you an idea of how math optimization can shape an industry, an entire industry. And to do so, I have made a pick and mix of some experiences we have had with our customers, mainly utilities customers in the field of waste. So here you can see represented a journey of waste from the collection to the final destination, which can be a transformation into a new resource or maybe transformation in energy. Okay, so we have to start from collection, waste collection. Waste collection can be made in 2 ways. We have fixed services when, for example, you have door-to-door services in which I have to collect a specific waste in a specific day of the week in a specific street. Of course, I have to collect plastic on Monday and Thursday and paper on Wednesday and so on. And on the other hand, we have on-demand services. On-demand services are related to those ways. For example, a citizen that calls the utility to collect furniture, or maybe I have to collect a container located in a collection center in the city, and the container is full, so I have to empty the container before continue the waste collection. First of all, collection of waste in the case of fixed services. Starting point is the territory. So the territory produces waste, how much waste, which kind of waste, where the waste is produced, and we have data. We have data from which we can do all the analysis we need to simulate the demand. So before design the new services for waste collection, we need to understand the territory. So we can do this mostly with data analytics, but we also build simulation tools to understand how the waste is produced in the territory. Then we have 2 main kind of problems. First of all, we have to define collection zones. So how can group the streets of the city to be collected in the most efficient way during the week, and to use at their best my assets. Assets are vehicles and operators. So we do this through a 2 steps optimization. First of all, clustering. So we use clustering techniques to shape the territory in collection zones. And then we apply to these zones routing algorithm, very specific routing algorithm to define the best trips for collecting the waste. Just to give you an idea of which kind of problem we have to tackle with this kind of solutions. Here we have a short list. Here we have the list. Of course, I can help companies understand, for example, how much does it cost to shift from a street collection service to a door-to-door service? Typical problem in the last 7 or 8 years. I can help companies to define how much does it cost to give the service to the municipality of a city in a tender. And of course, we have also other kind of problems, such as assessment of the calendar, when I have to review the calendar, because maybe percentage of separated collection shift from 50% to 75%, and then I have to modify the service I give to the city. As for the on-demand services, totally different kind of services, totally different kind of solution. Starting point here are, for example, call center, the citizen calling for, I have an armchair to be collected. or maybe also signals from IoT devices. I have containers and recycling centers telling me when the container is full, and then I have to empty the container. And other kind of inputs are, for example, a forecasting of the filling of a single bin or a single container, and so on. And in this case, just to go through the optimization side of the problem, we have several kind of solutions. Before talking about the daily planning and so routing problems, very important part of the process is the capacity planning, because of course I have on-demand services. I can forecast on-demand service, but of course the quality of the forecasting depends to the phenomenon I have to monitor. But I have not full capability to have flexible capacity. I have to say that tomorrow I will have 5 operators or 10 operators, but not only for tomorrow. In most of the cases, I have to tell which are the shifts for the next 1 week, 2 weeks. So every day I have a fixed capacity. So I have to define in advance, for example, a 10 to 8, 9 capacity planning. So how many operators I will need on the next 5 or 8 days, and then deal with this capacity day by day, depending on the trying to get the best out of this capacity every day, trying to follow the demand, the demand of on-demand services day by day. Another important part of the process in which we embed the optimization is adaptive design. Okay, so we collect actual data, so we can compare actual data versus planning data in order to define where to, for example, change the service, change the operative model, and so we can have a feedback on the service, and then we can change the operative models before the citizen complains about the waste collection. I've already told some of the cases. In this case, we have short business planning. We have typically we have no long-term planning issues to tackle with this kind of approach. Once you have collected the waste, we have to move the waste through plants, because the waste must be treated, the waste must be transformed, the waste must be stocked before entering the next phase of the transformation. And in general, when we talk about, for example, Italy, one of the biggest companies treating waste at the country level, we have a very complex network of plants, complex as a number of points and as kind of processes to be done in order to transform the waste into material. So we start from the network configuration, trying to do what? Trying to optimize the overall margin of the network. Overall margin is not only logistics cost of the transportation, but it is also and mostly the operative margin of the single plants. So I have to make the plants work at their best working conditions in terms of quantity of waste, quality of waste, and I have to have that quantity of waste in that single day. So this is a very complex problem, and we tackle this problem with the specific optimization models, again, in both long-term planning processes, budgeting and so on. Maybe I must define which plants to shut off, which plants oversize or redefine the dimensions and so on, but also short-term planning when we have to schedule. We are no more optimization flow models, but we have scheduling and routing problems at the daily and weekly planning of this kind of movements. And lastly, energy production optimization. I can transform waste into energy. We have great experience also in the energy field. Here we have, generally speaking, a schema of what we do about energy production. We have a digital twin of the plants. And then we have, of course, all the daily data about, for example, working condition of the machines and temperature, weather forecast, and so on. And what we do, we try to optimize the overall margin of the plant. In this case, why I'm talking about energy production and waste, because, for example, cogeneration plants can take in input energy from a waste to energy plant, and then transform it into energy, both energy or heat feeding, for example, district heating network such those in Milan or Brescia, and so on. Again, we can support strategic decisions and operative decisions. In most cases, we have or a model that can be used in both ways. So, like a bottom-up approach, also in the strategic and long-term planning, and then we use the same model for the daily planning, taking into consideration, of course, all the operative constants we have. Okay, so I jump to the conclusion. My takeaway is everywhere we can we have to take a decision. We can have an optimization model, analytics model. So the only limit is the fantasy. In these 15 years, I've shown some examples collected in 15 years of history. So we have convinced the utility to use this kind of solutions to design new services for waste collection. We have convinced other energy companies to use this kind of solution to optimize the energy production, and so on. It's a journey. It's a journey also for us, but I think that wind is changing, and I can tell that in 10 years, more and more companies are waiting for this kind of solution to be integrated in their processes. Okay, thank you very much. And feel free to catch up during lunch or coffee break.
Thank you, Claudio. There's a question.
Are you able also to validate policies to stimulate the citizens to more effective policies to reduce waste, or what is effective, what is less effective situation of this type of things?
Okay.
Before asking, repeat the question.
Okay, sorry. The question is if we use this kind of solution also to help municipalities to assess their policies, okay, regarding, for example, CO2 production and so on, decarbonization at large. Okay, so in effect, we work mostly 100% with companies, with private companies. But for example, when we work with utilities, these kind of goals, decarbonization and so on, are one of the main goals that these utilities have. These utilities, in many cases, are also participated by the municipalities. So we don't use now this kind of solution to help municipality to assess their policies. Is it possible? Yes, it is possible. We have data. We can, for example, assess which is the impact of a new policy on waste collection. For example, if a municipality, I have many examples on the waste because I follow the waste market in person. For example, when a utility asks me, what about collecting plastic one day, once a week, or twice a week? It is an assessment of the impact on the operative model side. But there is another question. Okay, but which impact you have collecting twice a week versus once a week in terms, for example, of percentage of separate collection? This is a question that is very, very important for the utility because they want to know how much plastic I will collect instead of the dry component of the waste. So in a few words, we haven't done this directly with the municipality, but we do this in a direct way with the utilities working for municipalities.
Thank you, Claudio.